Hi everybody, this is Dr. Nageswara, Assistant Professor of Physics, SRR and Xavier Government Degree College, Autonomous, Vijayawada. We are discussing about different air liquefaction methods. In the previous class, we discussed about the Linde's air liquefier. But there is some difficulties in the Linde's air liquefier because whose efficiency is less. So to increase the efficiency of the liquefier, Claude designed one of the liquefier that is called Claude's air liquefier. In any air liquefiers, the main principles are two. One is a Joule-Thomson effect, and the second one is the principle of regenerative cooling. In which Claude's air liquefier also, he used these two techniques. One is Joule-Thomson effect, and the second one is principle of regenerative cooling. But here, Claude designed that a compressor having some type of lubricant whose temperature, even though very less, it does not going to the solid state. That is the specialty of the Claude air liquefier. So this is one of the model of the Claude's air liquefier, in which he adopted the adiabatic expansion of the gas. We know adiabatic expansion is nothing but there is no heat energy can shift from inside to the surroundings or surrounding into the system. So in this adiabatic expansion, the temperature of the gas decreases. In adiabatic expansion at low temperature, the main difficulty is the suitable lubricant for the moving part of expansion cylinder. You see here in this C1, C2 and C3, there is pistons we are using. For free moving of these pistons, there is some lubricant to be used. But most of the lubricants are in solid state at very low temperatures, because for the air liquefier, we want to get very low temperatures. So in such cases, here, that is Claude used one of the best lubricant that is called petroleum ether. This petroleum ether is viscous up to 113 Kelvin and cannot be solidified. So that is the specialty of the Claude air liquefier. The Claude air liquefier containing C1, C2 and C3 compressors. These are three pistons are used. There is air is filled through this point into the compressor C1, where we apply some pressure in this compressor C1. This highly pressured air is passing through the C1 into the C2 along this direction, where here also we will apply some of the pressure, and this pressured gas which is entered into the tube T1, which is passing through this tube T1 into heat exchangers E1, E2 and E3. So this is the main parts of the Claude's air liquefier. So in this case, at C1 compressor, we will apply nearly 40 atmospheric pressure. So that by applying this pressure, that the Joule-Thomson effect, or maybe at the porous experiment or porous plug, due to the more difference in pressure, the temperature changes very, very high. So that is what we are taking 40 atmosphere of pressure at a C1 and C2 compressors. So the compressed air is then flow through T1 tube. The tube T1 in turn passes through the three heat exchangers, that is E1, E2 and E3. Through these three heat exchangers, the gas which is passing along this direction. But the cool air from heat exchanger E1 divided into two parts at point A. So some of the air which is passing through the tube T1 in the same direction and enter into the heat exchanger E2. But the second pass is moving right side and passing through this tube and had entered into the compressor C3. So in C3, there is adiabatic expansion occurs, where this piston is connected with the lubricant, that is petroleum ether. One part continues to flow through tube T1, and of course, it is passing through the heat exchangers E2 as well as E3 also. This gas, which is passing through the nozzle N, where nozzle N at nozzle N, it occurs Joule-Thomson expansion. So its temperature decreases. So the second part flows through the C3 and where air expands adiabatically in this compressor. So the air pushes the piston C3 outwards so that it did some external work. So to do this external work, some internal energy is utilized so that its temperature decreases at C3. This air entered into the tube and into the tube T2, where this gas whose temperature decreases, which move along upwards through tube T2 and entered into the T2 cylinder, where of course once again we will apply 40 atmospheric pressure, which is passing through T1 again. So that there is the principle of regenerative cooling we are applying, so that again and again, which is passing through the heat exchangers E1, E2 and E3, then his temperature decreases. So when this air which is passing through the tube T1, which is passing through the E2, so that it meets the incoming air in heat exchanger E2. Of course, there is a cold temperature, or maybe this cool air, so that the temperature of the upcoming air further decreases its temperature. So the temperature of the incoming air is further decreased. The incoming gas then suffers Joule-Thomson expansion at nozzle N2. At this place, there is Joule-Thomson expansion occurs. This process of regenerative cooling is continued till air reaches its liquefaction temperature. So when its temperature reaches this liquefaction temperature, it is converted into the liquid state and collected in this Dewar flask. So this is the procedure to get the liquefied air by using the Claude's air liquefier. Thank you very much.